This is Unit 3, Linear Relationships, Lesson 2, Graphs of Proportional Relationships, and Activity 3, Different Scales. And actually in this activity you're going to see that one of the relationships is not linear. It's actually on a curve, and it's not a proportional relationship. We're going to see what a difference that makes when you compare the curve, that relationship that's on a curve, to a linear relationship that's on a straight line. So here's the relationship that's a curve. So you're filling a tank of water, and over time it fills, and in the beginning it fills really fast. We'll talk about what this means in a few moments. But imagine if you have a pail of water and you're filling it up. You might turn on the hose really high as you begin to fill up the pail, and as it gets closer and closer to the top, you might turn the hose down so you don't spill any water. Actually, a better image, and we'll talk about it in this way, I think this is a better way to look at it, is the race between the tortoise and the hare. The hare is going to be tank A. The hare, or the rabbit, starts out really, really fast, and then it starts to slow down, and I'll show you how that's slowing down in a few moments. And the other graph is the line. This is a constant rate. This would be the tortoise, or the turtle. Moves along at a constant rate, never changes, just kind of plods along and just really happy with life, and nothing really seems to bother it. And it moves at a rate of, and this is tank B filling at a rate of, the volume is half the units in time. So if you look at 1 minute, half of 1 minute is half of 1 as a unit is 1/2. So the volume of tank B in a minute is 1/2 of a liter. So this goes back to what we talked about before. This says that the vertical length, I keep saying length, the vertical units are 1/2 the horizontal units. So the horizontal units in this case is 1. The vertical unit in this case is 1/2. So don't look at the length. You have to think about the units. This is 5/10 or 1/2. So once again, the vertical unit, the vertical measure in units is 1/2 the horizontal measure in units. So the vertical measure is 1/2 of 1, which is 1/2. So this number of vertical units is 1/2. Yeah, keep thinking about it. All right, so we start out. So this is one graph. Notice this goes out to 2 minutes. So the time is 2 minutes, and the volume is 2 liters. So it goes up to 2 liters in 2 minutes. And then what they do is they extend this graph out farther. So this goes out now to 100 minutes and 60 liters. So much further out and much greater volume as you're filling these tanks. And in this case, if it's a tortoise and a hare, as you're running the race, you're going much farther. And that 2 minutes is way down here. I'm going to show you where that is. Yeah. So this is the 2 minutes and the 2 liters way down here. And then they've just zoomed out so you can see the whole graph going out to 100 minutes and 60 liters. And this is that zoomed in region. This is the same graph as this one. This is 2 minutes and 2 liters. All right, so let's start to see what happens. Let's compare these. And what we're going to do is compare these two graphs at a half a minute. So right here, and you're going to look at what happens in 1/2 of a minute. And then if you double that time to 1 minute, you're going to see that the proportional relationship doubles, because that's what happens in a proportional relationship. If you double one of the properties, the other property doubles. But in a non-proportional relationship, which is tank A, you're going to see that the volume does not double. It's slowing down, actually, so it doesn't double. And then we're going to double that time to 2 minutes. And you're going to see once again that the volume for tank B doubles again. But the volume for tank A is even less than double. It's really slowing down. Then we'll go farther out. But let's look at these first. So we're going to zoom in on this graph to right here. So let's look at half a minute. So this is tank B, and this is tank A. So you can again think of this as the rabbit starts out really, really fast, and it's way ahead of the turtle, or it's way ahead. Tank A is way ahead of tank B as far as the volume that's filling. Now the equation for tank B is its volume, its number of units, is equal to 1/2 the units in time. So if the time is half a minute, that means the volume is half of that half, which is 1/4. So it's 1/4 of a liter in 1/2 of a minute. And tank A does not follow an equation, or at least an equation is not given to you. So you just look at a half a minute, and it has more than half of a liter. It has about 55 hundredths of a liter. So this is about 55 hundredths. This is about 6/10 or 60 hundredths. All right, so what happens if you double the time, if you go from half a minute to 1 minute? So notice that tank B has doubled in volume. Tank B has gone from 1/4 of a liter, this is tank B right here, 1/4 of a liter to half of a liter. That's double. So 1/4 to 1/2 is 2 times 1/4, or 2/4, which is the same as 1/2. So out here at 1 minute, tank B has doubled. But tank A has not doubled. Tank A has gone from, this is tank A right here, and this gets hard because there's lots of arrows, lots of lines, but tank A is right here. So in half a minute, tank A is at 55 hundredths of a liter, right there. And in 1 minute, tank A goes to 1 whole liter. That's 100 hundredths. So that's less than double. Double would be 1 1/10 liters. 2 times 55 is 110, or 1 1/10 liters, but it's less than doubling. It's actually slowing down. So this is like the rabbit starts out really fast and then starts to get tired, starts to slow down, but the turtle, or the tortoise, goes at the same rate, doesn't change. It is called a constant rate. All right, so let's see what happens at, that was 1 minute. Let's see what happens at 2 minutes. So now if you double the time from 1 minute to 2 minutes for tank B, or the turtle, it should double. So it goes from 1/2 of a liter. So 2 times 1/2 is 1 whole liter, and it does. Tank B for 2 minutes, you go up here for 2 minutes, and it intersects its line right here, and you go across here, and you see that in 2 minutes, tank B has 1 liter. So remember that tank B follows this equation of having 1/2 the units in liters as the time. So if the time is 2 minutes, the units in liters is going to be 1 liter. 1/2 of 2 is 1. So the volume for tank B is 1 liter. But notice what happens to tank A. Tank A after 1 minute was at 1 liter. But now after 2 minutes, tank A is up here, and you go across. Tank A is much less than much less than doubling 1. So 2 times 1 would be 2. Should be up here. So it's significantly less than doubling. So it's really starting to slow down. So tank B is getting closer and closer over time to tank A. That's like the tortoise, or the turtle, is gradually starting to catch up to the rabbit. The rabbit's really starting to slow down. Okay, now let's zoom out and see what happens when you zoom out. So if you look at tank B, when do they both have 20 liters of volume? So it takes tank A about 36 minutes, a little bit less than 40 minutes, about 36 minutes to get the 20 liters in it, whereas it takes tank B 40 minutes. So just 4 minutes longer, and tank B has the same amount as tank A. So that's not very much longer. And so if you look at this curve, right in here, they're going at about the same speed, or the same rate. And if they kept that up, then tank A would always be ahead of tank B, or you think about the rabbit would always be ahead of the turtle. But then the tank A starts to slow down even more, or the rabbit gets even more tired. And so it's slowing down, slowing down, slowing down. So it's getting closer and closer and closer. So at 20 liters, they're almost tied, and they actually are even at 64 minutes. So in 64 minutes, they both have 32 liters. So they both are at the same point after 64 minutes. That's like the turtle is finally caught after 64 minutes of the race. The turtle has finally caught the rabbit. And the rabbit's really slowing down. And the rabbit actually slows down so much as you get way out here, slows down to really, really slow, essentially a crawl. And the turtle, once again, or the tortoise, just keeps on going. The same constant, steady rate, slow and steady. Zoom in. This is the 36 minutes for tank A, 40 minutes for tank B to get to 20 liters. So here's the 20 liters after 36 minutes for tank A, and 20 liters after 40 minutes for tank B. And zoom out again so you can see the whole thing. 36 minutes, 40 minutes, and they are tied at 64 minutes with both having 32 liters. And again, let me remind you that this 2 minutes part of the graph is way down here. And that is it. All right, so here it is zoomed out again. So just remember that this curve, you have to be careful where you're looking at. If you look at this 2 minutes, you think that tank A is always going to be way ahead of tank B. Well, there's no way that's going to catch up. It's always going to be a lot more in tank A than tank B. But because it's slowing down, eventually tank B will catch up because that's filling at a constant rate, whereas tank A is slowing down. All right, that's activity 3.